Okay, the final section from Unit 7 is Unit 7, Section H3. It's Honors 3. It's going to be finding the area of a triangle using a sine ratio. And at the end of this unit or section, you should be able to find the area of a triangle using the sine ratio. So, if you remember to the area of a triangle, well, that's not really helpful, is it? Let me see if I can find another one. Area of a triangle equals 1/2 of the base times the height. Okay, 1/2 times the base times the height of the height. Okay, so I have this triangle here, right? And I can call this the base, right? But what is the height? Well, I'm gonna drop a horizontal. I guess I'm gonna call it a vertical. I'm gonna drop a vertical line down here from A, cutting it into two, not necessarily two, equal halves, but it does make a 90-degree angle here, making two 90-degree or two right triangles. Okay, and of course our opposite line segments, we'll mark them as, this is where my blue one go here. This would be line segment C. That's line segment little c. This entire line segment would be line segment A, and this line segment over here would be line segment little b, right? Because they're opposite of their angles. Right, and this little point here that we made, that is point D. So, and then this line here, we're just going to call that H for height. That's the height of our triangle. All right, so we're gonna substitute some of these things in here. We're going to substitute some of these terms with some terms in the terms of cos or of sine, right? So say we already kind of like split A in half, so we're not going to use A, but we're going to use C here as theta and B as theta. We can use it in two different ways here. Okay, so we're gonna write A in two different variations in terms of B and in terms of C for theta. So we're gonna do C. Let me make two columns, one for C and one for B. Okay, all right. So if C is theta, then we're talking about triangle ACD, right? If C is theta, then what is the sine of theta, right? So what is the sine of C? Sine of C equals our opposite, which is H over B. Okay, and then our sine of B for triangle ADB, our sine of B here equals our opposite, which is H, over our hypotenuse, which is C. Oh, that's the at sign. I got too fancy, which is C. Okay, so what is the common term in both of these? It's pretty obvious that it's H. All right, so we'll solve both of these for H. So this is B times the sine of C equals H. And we'll also say that C times the sine of B equals h equals h. All right, so now let's take these and we're going to substitute these on for each one of these. These are independent, right? These are just two different ways that we could find the area, right, for this triangle. And we're going to substitute it for h in this equation. Okay, our base here, what is our base here? In this equation, our base is a. A is our base. Okay, notice we're not using the sine of a, right? A is our base. Okay, it's the length that we're not using. Okay, so to solve for our area for using triangle ACD, right, we're going to be our area is going to be equal to 1/2 the base, which is A, times, that's an ugly A, let me try again, 1/2 A times, substituting B sine of C, and that's it. Okay, and then for this one, it's going to be our area equals 1/2 A times C sine of B. So that was that one. Now, say for instance we just shifted our hypotenuse around, or shifted our h around, and we made h go from here to here, right? Then our base would be C, right? And then what would, if we were trying to figure out, if we were using sine of A, right? If we use the sine of A, what do you think, using the same pattern, our area would be 1/2. We would be using, what would be our base? If we were using sine of A, we would be using B, and if we're using C, it would be C sine of B. So we're using the two. Let's do BC sine of A. The two other line segments of the angle that we're not referring to, right? You see how that pattern is? Remember, here A stands for area. Okay, so A is not the angle. A stands for area. But in this bundle of references here, the sine of A, the sine of C, and the sine of B, these are all referring to angles. And you multiply each one of those sines of those angles by the other two line segments of the corresponding angles. And then you multiply it by half. Okay? So that's how an easy way to remember it, right? What you look at the two line segments you have, and you multiply it by the other angle's sine, right? That's why it's so important to match the opposite side's angle to the letter, like this. Little b little b's opposite of the angle B. Little c is opposite the big C. Right? I tried to impress upon that to you way back in like Unit 4 or something. It's to get used to marking your sides like that. Right now, you didn't do letters like your corresponding sides with 3 arcs and then 3 slashes. Now you're going to be doing with letters. All right, so let's do a real quick problem. Okay, So let me pause it while I set it up. Hopefully it doesn't freeze on me or lose continuity. All right, so it has a triangle. It says that the measure of angle C is 41 degrees. It says that the AC, so that's B. That's B. So AC, that's also known as B, is 55 degrees. And it says that BC, also known as A, is 73 degrees. So what is the area? Okay, so we know the area equals 1/2 the base times the height. All right, so now we figure out what didn't it give us. Right, so what didn't it give? It gave us A and B. Right, so we're going to be using the sine of C because that's the angle it gave us. Right, so the sine, so area, area is going to be equal to the 1/2 of B and A, 1/2 AB, and the sine of C. That's it, right? It gave us A, it gave us B, and then we're going to use the sine of C, right? It's pretty easy when it gives us, when you kind of see what it's giving you. You just multiply it all together, right? Yeah, and it only gives you two line segments and an angle. You multiply the line segments together and the sine of the angle, and you divide it by 2, right? You could also say it's equal to AB and the sine of C divided by 2. That is algebraically the same. Okay. So that's going to be equal to 55 times 73 times the sine of 41, and that's going to be divided by 2. Okay, so that kind of looks like a parentheses, doesn't it? Okay, so 55 times, first I'm going to do this. First I'm going to do the sine of 41. 41 sine, okay? So times 55 times 73 equals, divided by 2, hold on, is 1,000 area. That makes sense. The area equals 1,317 whatever units squared, right? That's going to be units squared. So there you go. So hopefully that's pretty simple. If you have any questions there, this, by the way, are the things to use. But what's really important is that you just recognize what is given to you. Multiply the two together, multiply the angle together, and then divide by 2. It's pretty straightforward. Okay. I hope you guys understand all this. If you have any questions, please let me know.